Hello again. Thanks for sticking with me. This is another project for the Riparian pot. Another planting project, has a lot of similarities. One big dissimilarity is the fact that it's on the Yakama River near Toppenish, not on Sadis Creek. So the setting's quite different, as are the reasons why the forest is in decline. But it is in decline. Skip this slide. There it is, that red dot. It's about 20 minutes from Yakama. If you drive down 82, Big Flint Road, and if you go into the Pike, you're in the Pond 5 parking area and the DFW Sunnyside Wildlife area, you'll be very close to it. It's in the Wapto Reach, so it supports in some way or another just about every fish species that runs up and down the Yakama River. There are I listed the concerns by adults and juveniles. Water temperature is prominent. This project may have some effect on water temperature long-term. More interested in juvenile concerns, especially spring Chinook parr and smolt rearing in the winter. There's pretty good evidence that they use this reach during that time. The river, if anyone has seen it, could use a lot more cover, and a lot more sorting of gravel and a lot more sort of hydraulic and geomorphic variability. And one thing I don't hear a lot about, be interesting to talk about it with you guys some other time, is, the extent to which fall and summer Chinook might use it for fry rearing on the shoulder seasons. Don't know, but they have every reason to be there. And if we can provide a little more cover and shallow water habitat, that'd be great. And then of course, fall Chinook do spawn in this reach, mostly downstream, but they do make it up here. And any wood inputs, here's the beneficial effects of the project with respect to those ecological concerns. And they're similar to things you would expect. I'll talk about two in a second that are a little more specific. What we talked about on Sadis Creek, more in-channel complexity, more cover, forced pools by large logs. Cottonwoods don't do it the same way, say, giant red cedars do, but they do create jams, and they do get in the water and help with gravel sorting and such. So all of these things, we're talking about aquatic habitat complexity. Long-term, the wood in the stream is going to help a lot. We're not looking at shade from trees here on the Yakama River, except maybe on side channels, and that's not the setting here. The river is very wide relative to the height of cottonwood trees, and so we don't expect to see a lot of shade benefit. But one thing that's been suggested by several geomorphological studies and also by Chris Para, who's a lower river habitat lead, is that it's possible, it's a hypothesis, that if you get more trees on gravel bars, or right now there's a distinct paucity of them, you will help slightly narrow and deepen channels, which could incrementally prevent water from warming. I want to say it that way because you're not cooling water, you're preventing it from warming up as it moves downstream. So I say buffer against downstream temperature increase. So that is a possible outcome. Hypothetically, only way to find out really is to do it and see. That's going to require a long-term monitoring effort. So it will be interesting if this is successful and we get around to doing it and have good success. But it could be significant given climate change and the number of fish that use this during the spring and fall. Ecosystem function again, I'm not going to spend time, except this is a different photo. There's a goose friend sitting in a flood on the Yakama River floodplain. It's a beautiful place. Steelhead recovery plan. This is very well acknowledged basin-wide action to improve improvement of cottonwoods, and then protect and restore main stem and floodplain habitats. It is also, I'm thinking that these focus area things should add up, right? It should be cumulative.
Multiply.
Yeah, a multiply. Okay, so I'm gonna get 400 points. I'm pretty happy about that. We're getting two focus project there. So, purpose and goals. Number one, is to support the continued existence and restoration of our naturalist fish runs, none of which are doing awesome. Particularly steelhead right now is really having a hard time. That depends on this reach. There's just this desire to increase and maintain forest cover, which is declining, and then restore and maintain all those ecosystem functions that we talked about. And this is an example of cottonwoods in the water. You don't think of it, but this is on the Wapto Reach after a big flood, and a lot of them went in, and you can see they have significant effect and a significant presence. Okay, so we had this thing that was done in 2021, completed then, called the Wapto Reach Riparian Assessment, done by Natural Systems Design. This one turned out very happily. I think I'm happy to share it with anybody. It's a large amount of material and it's a good report. It seems like a lot more effort was put into it than some of the other work they did in this basin. And so this is just a part of it. One big thing they did a couple different things. One of the big things they did is they did a mapping exercise. They mapped the forest in 1949 from good quality aerial photos we have from them, and then they mapped it in 2015. So it's a bit like that SATA study. And they really focused in on two distinct focus areas. One of them is this one, that yellow star is the project site, that orange boundary is the focus area. And then I want to call your attention to that red hash line around the river. That is the active channel migration zone. That's just created by overlapping channels from mapped channels over the years since the 1930s to about now. So that's everywhere the river's been, that's the active channel zone. And they then just did math with their polygons in GIS. And they resulted in maps like this for this focus area and another focus area downstream. And you have three different colors here. You have the blue water, but then the dark blue is forest that stayed the same. The green is forest that revegetated and regenerated. The red is forest that was lost. So they did this mapping, and what they were looking at was net change, right? You want loss minus gain or gain minus loss, whatever you do. You want something that captures the net change, and that's what they were after. So what you'll see here, this is everywhere, not just, but if you imagine that thin channel migration zone, there's a lot more red than green, and there's a fair amount of blue. The results were troubling, if you like riparian forest. This is on the upper left, is total acres in the upper focused area restricted to that channel migration zone. Restricted. So this is the area where the river is interacting directly with the forest. And you can see the orange is 2015. There's less. Surprise, surprise, there's less forest. If you go to the bottom right, you see habitat type. They broke it into all these different habitat types. And you can see the story is kind of different. This chart relates to the upper focus area again. Different things happen, but in effect, the total cover of forest and of mature close canopy forest is much less. Between the upper and lower focus areas, 40 to 50% loss was documented from 49 to 2015 in the channel migration zone. It's less outside of the channel migration zone, and that's the story, right? That tells the story. And if you just do simple projections, I'm not claiming this is a model. If you take that loss rate per year and you multiply out to 2,100, that's about 75 years, 77 years. The net thing we need to keep up, we need to restore or conserve from loss is about 30 acres a year. If we want to maintain the forest we have in the channel migration zone now, that is a lot of planting, a lot of something. Otherwise, the forest is going to be declining if we assume that it continues to be lost at that same rate. That's probably not a great assumption, but we don't have a better one right now. So this is a sort of, in a way, a worst case, maybe not worst case, but a pretty bad case scenario, but I think it's one worth considering because of the value of this forest.
Okay, can I just ask a quick question? So the number of acres total shouldn't change much, right? So have they mostly converted to gravel bars, weed patches? What's there where the forest used to be in terms of those few hundred acres?
That's a great question. They did not map that because they were interested in the forest itself, and it's time consuming and expensive. My observations are a combination of largely exposed gravel, and also scrub, willow scrub, annual plants, things like that. You know, wherever enough soil builds up that things can grow, there's a lot of annual cheatgrass areas, reed canary grass, things like that. But non-forest, largely non-scrub.
Thanks.
Good question. We should figure that out. Okay, so this is, on the left is the setting on the reach. The upper left, that's the bridge at Wapato. The lower right of that left-hand image, the first bridge at Toppenish. Those yellow polygons are areas that are potential planting areas in that reach. That's about 170 acres. And the red one is our area today, Pond 5 reach. That's red. But the other thing I want to draw your attention to is you can see that there's a broad band of forest now. It's dark green set between the ag and the highway. And my interpretation of this story of forest loss is that we had, before regulation by dams and diversion for agriculture, we had a much bigger river. The loss of flood power has been about 50%. It used to be a rambunctious thing, the Yakama River, and it had a much broader active floodplain. In fact, that place where the highway kind of dips down to the right of the picture there, the Buena Loop area, that used to be part of the floodplain. Dale Mack with the county did a flood model and showed pretty clearly that water used to go past up there around, over towards the Yakama Valley Highway. So the floodplain has been dramatically constricted, much bigger, more rambunctious river, much more bare substrate, which cottonwoods need. So we created this broad band of forest. Now we have a smaller river, but it's still migrating in that broad band and it's slowly chewing away at that forest without replenishing it. It's slowly, and that's where the loss is coming from in the channel migration zone. So over time, as the migration corridor moves around, it's gonna slowly eat into it because it has enough blood power to cut into banks, recruit trees, all things we want. There's that 5 again. I get there before I even know it. Anyway, so this is what's happening. We got the loss. The zoom in on the upper right is just showing 2 dashed possible site access lines. I'm talking to the state about it. They're in favor. I just need interestingly, this site is considered to be on Yakama Nation land. The state agrees with that because it's on an island. So all we need from the state is an access permit through the Pond 5 area. You can get medium-sized excavators under that too, so we can get big enough equipment for what we need. Zooming in, it's an alluvial bar. This light blue and green areas and the trees show areas where we will not be planting. The light blue is too low, the green is too wet, the trees are already there. So we're left with that center area, which has a lot of scrub. I'm just gonna skip the technical details to get right to what we're gonna do. I broke down the bar into energy zones. Anyone that's been out there knows that if you're on the top end of the bar, the orange is high energy and low elevation, because those 2 things really control the substrate and the water table, things which trees depend on. The upstream end of the bar on your upper left, that gets a lot of impact. You have large substrate, cobbles and large gravels. You get midway through the bar, there's less energy, maybe a little higher, and at the tail end of the bar, it's kind of low, too high, depending on the deposit, but really low energy to get sand deposits. So the setting really changes a lot upstream to downstream on a fair sized bar like this. That's a 250 meter scale bar. So this is, almost a kilometer, 3/4 of a kilometer long. There's highly variable surface and water table conditions on this bar. And then the white bars, the little white marks I want you to look at, because those are shelter structures for plantings. That's what they are.
I'm sorry.
That's all right. I was there. I was there. So people of a certain age know what that means. Give me shelter, know what that refers to. It's all about creating safe sites for seedlings. There was a famous paper in the riparian world done in 2006 by Stuart Root and Mary Louise Bolton on the Kootenai River. They found that cottonwoods really need these protected areas not to get washed away by floods in addition to elevation. NSD did some cool imagining. They found seedlings behind log jams. I don't know if I can see, is the laser? It's not on. In the upper right, I have 2 red arrows, and I don't know if you can see it. It's kind of small, but there are logs that fell on this point bar and all the riparian veg is downstream of those logs because it protected them from scour and from a lot of times on this river, you get a lot of gravel crawling up out of the bed basically during floods, and it'll just plop down on seedlings and kill them. So the big logs do that. So we want to put these big logs into our planting plan and protect our vulnerable plantings so they're safe. Through structures on the lower right, that's basically the simplest way that we could think of. I think that's what we're going to use. Large logs pinned in place with smaller piles driven at angles to keep them from floating. That's the main thing that's going to happen. They're going to want to float away if the water gets high enough. So that's the plan, plant and protect. I did complete a riparian enhancement plan for this one. It's already in pretty good shape. If you want to look at it on, I always get my thing on Prism. It's very detailed. I wrote the species and the planting method down by zone. If you have questions, we can go back to this slide. It amounts to about 29,000 plants. It's a lot of plants. It's over 20 acres within this 30-acre site. It's a big site. I used the same, you saw those numbers on the SATUS project. It's the same kind of thinking. About 1,500 an acre with 30% mortality over 5 years results in about 1,000 stems an acre. That's pretty dense, but if you look at a cottonwood forest as it naturally recruits, it does that too. It thins itself out. If you want a good forest, you should allow for mortality on down the road. So I think that's a good spacing if we get there, if we're successful, year 5. Same task and timeline essentially. I'm gonna move on through that one. It's very similar. Cost estimate, very similar too, for the same reasons. I derived it the same way. In addition to planting, which is already expensive, we're building structures. They have to be designed. They're cheap structures. They shouldn't take a lot. There is going to be a hydraulic model involved, both to determine where they're needed, where the high energy zones are, and how robust the pinnings need to be to keep them from floating, right? What the energy impact they're going to get is. So we do need hydraulic models for that. We do need engineering, I think. We thought about it. Same derivation exactly. I'm not going to spend time on that slide. and potential constraints, a little different, still have low water table and ungulates and beavers, that's very same. Access, I think is feasible along the levee, and then we're gonna have to build a ramp and cross a side channel. I think that the permitters will be okay with that as long as we limit our crossings. It's a shallow side channel, it shouldn't be a difficulty for machinery, but yeah, it is something to think about. And that's it. I guess I'll leave a lot of time for questions so we can kind of get to where you guys want to get into, but in some ways, the approach is very similar to Sada's. The goals are different because we don't have shade as a goal. We have a more geomorphic, large scale geomorphic effect. And we're dealing with very well documented, pretty high rates of loss that I think we need to address very soon. Talk about that, you know, this is, if you're curious, we can get into this graph, which sort of, in my mind, is the root cause of why we're experiencing loss, but for now, just leave it there.
I was gonna say, under the status of the methodology, has that been tested with the logs and things like that with the cottonwood?
Well,
I saw someone was a success rate.
that technique of logs has been tested actually in the Upper Columbia. Some project on Nason Creek, IFI designed something like that. A potential plant designer here designed those logs, which I showed you in the picture. And they were used for protecting plants in a natural flow stream where plants were recruiting naturally. So I don't know if it's been tested. My feeling is it has. Mid Columbia has recently done flood fencing that's fairly similar to Harris property. So we'll see how that works out. It's something that's starting to be done more, I think, so.
It's definitely something you observe on.
Yeah.
On flood
You see
bars.
plants behind logs.
Yeah, I mean, it
Yeah.
seems pretty high likelihood of
Yeah.
success. I got a couple questions about ways to make it cheaper.
Sure.
Essentially. So 2 questions. So the log thing, I mean, do you really need to do hydraulic modeling and all that stuff, or can you just put in some structures? Could the structures be rock rather than log? So that it's something more
Can I,
sustainable?
I'm trying to get it back.
yes, the answer is yes, it could be rock.
I know rock's out of fashion.
It is out of fashion. I mean, you couldn't use, so when we were out there with Tim Abbey, Tim Abbey thinks of an idea every 2 seconds. And, you know, the
But
difficulty
they all
is
involve wood.
culling, no, in fact, they don't involve wood.
Okay.
So, thanks, Bridget. Oh, Bridget, could you go back to, okay, great,
You should have control now,
I don't know if I do, I don't think I do quite yet.
right now. There we go. I just have to click on it.
Sorry. Okay. Give me shelter. So. The laser's not working for some reason very well. But, that lower left is actually a Tim Abbey design. And he called them caddis baskets, where we use some form of biodegradable netting, jute netting. Take a small mini X or Bobcat and push cobble into those and make these rolls or bricks with it. And you have something that eventually will go away, but should last for 5 years. A big pile of river cobble, locally sourced, right there. I'm sympathetic to that. The details need to be worked out, like a lot of Tim's ideas, but could work. Could use big rock. I'm less in favor of that because it's gonna be there forever and it could do weird things
Oh,
hydraulically.
I like that better.
You like the big rock?
No, I like
Yeah.
this idea. I don't even know if you need the burlap or whatever.
Yeah, pile of cobble. If the big flood comes, it's gonna wash away. So the answer is, yeah, we're all into trying that. And looking at alternatives in our design. Hauling logs is expensive. It doesn't take a ton of big logs though, right? If you,
No, it's not the logs, it's the engineering and
Yeah.
the modeling and the, all that
and
stuff.
the reason I think modeling could be advantageous is it will pinpoint where it's needed. That to me is the biggest worry, is you just put it in a place where it doesn't matter. Or you don't put enough where it does matter. I think that, because they're gonna be expensive to build, they're more expensive than other things to build. You know, you'd rather not waste your effort putting it someplace where it's not the right spot. So to me, that's a good, you know. I'm totally open to talking about doing just a seat of the pants thing. I think my feeling is you get better results with hydraulic model because you can see where the energy was.
I think you would too, but I think the cost, I think the ratio, you know, your likelihood, your certainty would go up, but I think your cost would go up more, would be my guess, than having a guy run around with an excavator for a couple days making it.
And it's an interesting idea, you know, you get a good geomorphologist out there, they may say, yeah, I could give you somewhat better results if I did a model, but I can give a pretty good shot just by walking around and looking at evidence from the field, right?
Yeah,
Because those people can tell, you can tell by the deposits, and so I think that's definitely something we'll look into. We're not into spending as much as we can, you know, I put this because might be, most very conservative estimate. If we can save by approaches like that, I'm totally into it, and we'll certainly have that in our RFP for designs.
okay, my other question along these lines of sort of cost savings is, what about the idea instead of, I'm thinking this saves money, I mean, I've been involved in projects a long time ago where this was done to save money. Not so much bare root, not so much even spacing, but again, getting an excavator out there, digging trenches, loading trenches with
Oh, yeah.
deep stakes, backfilling them.
Oh, yeah, that's in there. That's in the plan. That approach is described exactly in the enhancement plan. Here's the thing, there's a mix of bare roots. There's a nursery in Seattle that does a good job of cutting bare roots from seed. One advantage there is you get genetic diversity. And you just plant a lot of them. They're 50 cents a piece.
Well, it's the labor though.
It's the labor, but you're doing that by machine. And then you have nursery stock, which has been shown to have high survival, very high quality, and then you have that approach. And I don't think we'll really find out what works best in this setting until we do it for a little bit. It's and so that mix is in there. And part of the design package is going to be finalizing the riparian enhancement plan and dialing that in. So yeah, that thing you just mentioned is totally in there.
Are there radically different costs? Like, that's what I have in my mind. I could be wrong, like on a per
Yeah,
acre
because a
basis.
big tall tree pot correctly grown is about $9 a pot. And collecting a stake is much cheaper.
Yeah, and I'm thinking installation is a lot cheaper if it's
Oh,
just digging a trench and.
Could be, you still have to backfill carefully, you still have to do a lot of things carefully. You're gonna use an excavator either way. You're not gonna be digging around by hand in any sort of high situation out there, so I don't know about the planting cost, but the per plant cost, it's really, really different. Your survival's lower, so it's all about those trade-offs,
Right.
so I think those are great.
The
approaches.
cost at end of 5 years.
Yeah.
Questions from others on this project? If you're trenching, have you considered any form of flood fencing as a possible? I know in the original Wapato assessment, we were looking at that a bit. Yeah.
That is kind of flippant.
I was thinking of sort of vertical bowls that are hoped for to resprout.
Oh, live flood fences?
Yeah.
Good.
Snohomish style.
Yeah, Snohomish is a lot wetter than here.
Yeah.
Good ideas. I'm not stuck in any preconceived thing here. I think there's some good ideas in what we have, and I'm open to these kinds of things. I don't know if, I mean, live flood fencing could work. Live flood fencing is not gonna not gonna duplicate the piles of wood you see out there already in terms of its ability to stop a big sediment slug or to cause a leak. So much that deposits a lot of sand and protects the plants, especially right off the bat. So maybe a mix of them.
Yeah, the Snohomish one, I mean, the flood fencing idea was just roughness and aggradation. It wasn't there for the seedlings like you're
Yeah.
describing, but there's still benefits to doing.
Well, it's racking that then provides.
Well, racking as
against the
well.
fence,
Yeah.
that then provide. Yeah, other questions?
Tom, what would be the best installation window for survival in your mind?
As late as you can in the water year before it comes up. So the planting, the lowest line on that map is set by about average winter flow of about 3,500 or 3,000. So none of the zones are any lower than that. So you can still get in there if it comes up a little bit after irrigation season. But you don't want to go past Thanksgiving in my experience, because then you could get a flood anytime. And no one's gonna be happy about having the machinery sitting out on the bar. But so it's probably October and November. It's gonna be a 2-month project, I'm sure, because it's fairly extensive. So you want to be out there in September mowing and then work. Plant, especially those bare root things need to go in with the pool.
Would they be dormant during installation? Plantings?
The bare roots would be, and yeah, everything would be heading towards dormancy. You want to also, you have that problem of collecting stakes late enough that are already, so they're dormant in time to hit your planting window before the floods. It's kind of it's a real precise timing. So they're shutting down by the end of October, then you only have a little time before the floods might come. So I think it's gonna be do as much prep as you can and then slam things in the last week of October and first couple weeks of November, till Thanksgiving probably. There's some sort of switch in probability of a storm right around the middle of this November 17th is the threshold date slash shit, but there's something that happens there. The probability goes up a lot.
One more question or?
November 11th is our biggest innovation day.
What was that?
Oh, you're saying November 17th. Historically, for the last 11 years, November 11th is our biggest ungulate migration day. Like our callers move the most on that day every single year. It's just a huge push.
Something in the air.
Yeah, tell us now.
Awesome.
I guess, Sean, those cost saving things, should I find a way to put them to, and Elizabeth, I'm both listening, find a way to adjust the proposals to reflect those possibilities?
The discussion, and we should probably have with Elizabeth offline, is if you're going for a design construction and you need to have enough clarity on the design for the state review panel to be content. So we should talk about,
Like how we're gonna do design, what the.
well, and also enough about it to judge the outcomes. And because this is a hybrid design, riparian, it's sort of, it's new the way we're doing it.
Yeah.
So we should talk with Elizabeth about how much is it to your benefit to pick something and have it fairly narrowed for analysis versus open up to alternatives, or maybe some way where you can say, here's our plan, but in the design, we'll consider these alternatives.
That's kind of where it is now. That's what
Yeah.
I would do now, yeah.
But let's just talk with her about what'll work best for the review panel.
Okay.
I'll make a note of that.
Thanks, Tom.
Thank you, Tom.